Yeah, starting my recording, and today we're talking about angle properties. So basically, we're going to be looking at a paragraph where we're looking for missing angles, but we need to know some facts before we do that. What are the facts? The first one is that if you add two angles which give you 90, these are called complementary angles. And if they add up to 180, they're called supplementary angles. So sometimes we'll be using these terms, and I just want you to familiarize yourselves with them because then you'll be like, what is this about? Okay, so complementary and supplementary. Right, okay, so now let's talk about some other terminology here. Firstly, if you have two angles that have the same vertex, by the way, vertex is that little point at the end. So the point that creates your angle, really, because your angle needs to have two line segments which cross through the point. So this point is called the vertex. Okay, so that's the name of this point. But basically, what are these angles called? So two angles which have the same vertex and share a common arm, they're called adjacent angles. So in this case, what they mean is this. You see this AQ, the two angles, the one angle on top and the one below, they are sharing this blue line, which we'll call an arm. So these two are basically adjacent angles. And you see here we use PAQ with a little hat on top and QAR to indicate what angles we're talking about. So these angles are adjacent, and this blue bit in the middle is the so-called common arm. So that's what the textbook has referred to here as a common arm. Now, for intersecting lines, we've got, now we're getting into the juicy bit, okay? So this is a really important bit, so focus. For intersecting lines, angles which are directly opposite each other, they are called vertically opposite angles. Now, this vertically comes from this point here, because this point here is called the vertex, like we saw before. So these are vertically opposite because they're opposite on the other side of the vertex. That's where this name comes from. So vertically opposite angles, they are equal. So how do we remember this? Remember the X shape. So X shape. When you have an X shape, these angles we get in the middle, opposite each other actually, they are equal. And the same thing happens with the other angles, the other pairs of angles. So the red ones are also equal. So yes, that's pretty much the idea here. Let's move on now to some other facts. Angles around a point. I think everyone in this room, hopefully, knows that a full circle has 360 degrees, so if we do a full turn. So that means if you have three angles around a point, they add up to 360 degrees. That's pretty much it. The second fact, adjacent angles in a straight line. So we say angles in a straight line here add up to 180 degrees. Now, why is that? Let me just start doing some things here. Previously, we had 360, which is a full circle. But now we'll have half of it, and half of it is basically 180 degrees. Easy peasy, lemon squeezy. Right, moving on to the next bit, which is adjacent angles in a right triangle. So let me just go further down. If you have a right angle, not triangle, sorry, if you have a right angle, then we know that these two angles add up to 90, not 45, because we don't know that half and half could be 30 and 60, it could be 10 and 80, you know, it could be anything. But what we do know is they add up to 90 degrees. That's what we know here. If they give you a little square symbol, it means it's 90 degrees. If they don't give you the symbol, but it looks like there's a 90-degree angle there, it's not certain that that's 90 degrees. So please don't go ahead and assume it, because I've had so many students say, but it looks exactly like 90 degrees. So assume it's 90. But turns out it was 87.3, so you got it all wrong. Good luck. Right, moving on to the next one. Vertically opposite angles. We just had a look at that previously. They are equal. So, for example, this top angle here, A, is equal to the bottom angle, B. Cool. Moving on to another bit now. Corresponding angles. So corresponding angles. Here, let me just add a note. So vertically opposite angles. Remember these from the X shape. Now, corresponding angles, we have an F shape. We just need to spot it. So corresponding angles are the angles which appear in this part of the F letter of the letter F, in corresponding part of the letter F. So in this case, we would be given this A and this angle B. These two are equal to each other. But if they had given us the angles above, for example, above this red bit, say that they had given us, I'm going to use blue for this, say they had given us this angle and this angle. Well, the blue and the blue angle are also corresponding. They're also equal. So it doesn't have to be just this angle here below the red line. It could be the one above. It could also be the one on the top left. So the top left angle here and the top left angle down here, I suppose, they are also corresponding. Because what you could do here is you could think of this as an inverted F shape. So an upside down F shape, if you like. So play with your imagination a bit to see these letters F. And then obviously the bottom left is going to be equal to the bottom left as well. Okay, actually I'm going to introduce that as well, because I'm going to upload these annotations so you've got them. So this green one is equal to the green one. That was the last bit I said. Okay, let's move on further down. Let's see what else we've got to talk about today. Basically, this is the end of page 2. Let's move on to page 3. Right, hang in there, guys. Just a couple more definitions and then we are done. Co-interior angles. So co-interior angles, or allied angles, sometimes called, I think in the US, these are the angles formed by the so-called, or found in the so-called C shape. So where do we see that C shape? Well, C shape would normally be the shape found on the right. So those would be the angles in here and in here. What do we know about these angles? They add up to 180 degrees. So the sum would be 180 degrees, the sum of these angles. Now, this thing also happens with an inverted C shape. So in this case, they've given us this inverted C shape. It's like a C shape is when the reflection of that in the mirror. So that's an inverted C shape. We know that these angles also add up to 180, as long as they're inside the sandwich. So imagine inside the sandwich, on the same side of the sandwich, sort of, and they add up to 180. The other basic things we know, angles in a triangle add up to 180. We knew that from before. The exterior angle of a triangle. Guys, 2 more, hang in there, please. The exterior angle of a triangle, which means any of the 3 angles outside a triangle. If you extend one of the sides, you get an exterior angle. So what they've done here is that they've extended this bottom side and they've said, right, this angle is an exterior angle of this triangle. It's the angle C. What's the special connection between this angle and the other ones? Well, this one is always equal to the sum of the opposite angles in the triangle. I know this looks a bit strange, but this angle plus this angle is actually equal to this angle on the outside. There is no trick for this. There is no shape here. We just have to remember this. I think it's very easy to see when we have some numbers, but I'm not going to get into explaining why this is true at this time.
It's because, like, if you do 360 minus A and B, it will get that. So, like, the
180 minus A and B. It would be 180 minus D.
I forgot how to say. What's left behind is outside.
Yes, exactly, something like that. So, okay, I'll put a because here just because said it. Because this is equal to, if we call this theta, it's equal to 180 minus the other 2 angles. So then if you do 180 minus this to find the other one, you get A plus B. But I don't want to get into it. I don't want to confuse you. So let's put that there. And the final one, guys, the final bit of theory I have to talk about. I do apologize about my blabbering today. The angles in a quadrilateral is about to tell us what they add up to. So angles in a quadrilateral add up to. Excellent, nicely done, 360. Now this is true because you can easily see this if you split a quadrilateral into 2 triangles. Each of the triangles, they add up to 180, so you find the total, by adding 180 and 180, so you get 360. Moving on to example 1, finding the unknown. Find the angle A. So what is A equal to here, guys? A is 50, exactly. How did we get 50? Exactly. So we know that A plus 40 is 90. So A must be 50. Brilliant. That's it. Let's move on to another example so we can apply all the stuff we looked at today. Here, we want to find the unknown in this problem. So we want to find X. Now, this is an algebraic problem. So let's think about this. What have they really done here? Now, this might not look like it. It probably looks a bit strange. But let me show you. These 2 lines are parallel to each other. So since these 2 lines are parallel to each other, and then you have a line going through them that crosses both of them, then you have to notice that we've got a kind of an F shape. It just looks very weird. It's like this kind of F shape. So this is an F shape. But it's rotated and flipped, right? So it's like, yes? you see, if you rotate this, right, you do it like this, then you end up with this shape. So I know it's a bit tricky to see, but basically what we need to notice here is this. This angle they gave us here, angle X, is equal to the other angle they gave us here, which is 2x minus 100. So what have they really said? They've said that X is equal to 2x minus 100. Why? Because these are corresponding angles, F shape, and they're equal to each other. So how do we solve this problem? How do we solve this problem? Let's find X. What's your first step? No, how do we find X? We just finished the unit on algebra.
Okay.
Yes?
Yes. So first we need to put over 2x. So we need to put minus 2x. Yeah?
Okay, that's fine, yes.
So then
Minus 2x on both sides.
yeah.
What does that give us?
Minus x.
Minus x on the left, and then on the right?
Yeah.
Nothing. Minus 100. That's it. So what is x equal to? 100, exactly. So x is equal to 100 degrees. That's pretty much it. Well done. So I'm going to stop the recording here. I will leave this on here so we can get started immediately with this question. But I will upload my annotations on Google Classroom now so you can use those.